Okay, here we go with some exponent rules, and this time I'm going to demonstrate them a little bit differently. You should have some familiarity with what we're doing, so hopefully teaching it this way will really reinforce what they really are all about. All right, so let's start with 5 to the second power, something that we're used to, over 5 to the second power. And let's write it in expanded form first. So again, let's think of this as two fives up top, two fives down below. Stick with me here and hopefully this will all come together because right now this is pretty easy. Now 5 times 5 is simply 25 over 25, right? So if I think about 25 being divided by 25, that equals 1. Well, where am I going with this? Think about what we could have done to these exponents from the start. We could have subtracted, right? Because when we're dividing, we know that we can do 2 minus 2. And so 2 minus 2 is really 5 to the 0 power. And there you have it, which is equal to 1, because we know that 25 divided by 25 is really 1. So that means anything that's to the 0 power is really representing the same amount over the same amount. Okay? So if you think about it that way, hopefully things to the 0 power will help you out. Now, the next one is 5 to the first over 5 to the second. I'm going to stick with my expanded form where I write 1 5 and then 2 5s. Okay? Now, if I was to go ahead and multiply, this is 5 over 25, right? And 5 over 25 can be reduced. It cannot create a whole number. It can create a fraction of 1/5. So hopefully you're able to follow me there. Now let's take it to the exponent rules. The exponent rules would say that we would subtract and have 1 minus 2. Now 1 minus 2 would be 5 to the negative first. Now what did we just discover? That this is really 1 over 5, where the 5 should be in the bottom. Because remember back here we had 2 5s in the bottom, but only 1 5 in the top. Now where's this 5 at the end here? It's in the top. And that's what this is indicating. A negative exponent is saying I'm in the wrong spot. Put me near where I want to be, which is in the bottom, and then I'll become a positive 1. Okay? Lastly, let's talk about a number like 6 over 8, and we have variables. So no more actual values, but just variables that represent a value. So 6 out of 8. Well, let's reduce that. That would be 3 out of 4, because 2 can go into 6 3 times, 2 can go into 8 4 times. Now again, let's look at where we have more of that letter. I have 4 x's in the top, 1 x, put it in the bottom. I can go ahead and subtract and get 3, and I know based on the last example, if I keep it where it's supposed to be, it will be positive and it will be happy. Now, 2 y's in the top, 7 y's in the bottom, those will subtract and be left with 5. But where do those y's go? In the bottom, right? And then we don't have to worry about positive or negative because there are 7 y's here. And then finally, z to the third over z to the third. 3 minus 3 makes 0. Think about what we just talked about with the 5. It's really just a value of 1, which we don't have to end up writing because that would cancel out. So there you have it. 3x to the third over 4y to the fifth would be your answer. We don't have to worry about negative exponents when we leave those things where they should be. If there's more on the top, keep them there. More on the bottom, keep them in the bottom.